Hello guys, welcome to In 5 Minutes. In this presentation we are going to see codes. There are numerous codes which are employed in digital electronics or digital systems, and they are categorized into various manner. So depending upon their weight and the properties, we are categorized these into 4 different sections. There are weighted codes, non-weighted codes, alphanumeric codes, and error detection and correction code. We will see one by one. So very first code is weighted code. Now you are familiar with the weighted code because these are categorized particularly into 2 sections. That is nothing but first one is straight binary code and second one is the BCD code or the binary coded decimal, which is also called as 8421 code, because only 4 bits are used to represent BCD numbers and position of the bit has got a particular weight, that is nothing but 2 raised to power. 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4 and 2 raised to 3 is 8. Whereas straight binary code means it's a n bit code having power from LSB to MSB, 2 raised to 0, 2 raised to 1. Towards MSB it is 2 raised to nth power. So for nth bit code the power is 2 raised to n minus 1, starting from 0, that's why the power is 2 raised to n minus 1. So that's why it is called as weighted code, because each bit or the position of bit has got a particular weight. You can say 2 raised to 0, 2 raised to 1, it's a weight for that. Moving on to second part, that is nothing but the non-weighted codes. So for non-weighted codes again 2 parts are there, which are nothing but, you can say, first one is the XS3 code and gray code is the example for non-weighted codes, because in this particular codes we use binary numbers, zeros and ones, but the position of the number has not got any kind of weight, 2 raised to 0 power or 2 raised to n power. So that's why these kind of codes are called as non-weighted codes. Now in this particular session, the next topic, we will see the alphanumeric codes. What alphanumeric codes are? So they are also particularly categorized into 2 parts, but we will see it one by one. Let us try to understand the concept of alphanumeric codes. So alphanumeric code, it consists of alphabets plus numbers plus punctuation marks. Punctuation marks as in, you can say they are exclamatory marks or commas or semicolons or brackets, square brackets, hashtag. These are the various symbols which are called as punctuation marks. Alphabets, you can say A to Z, the uppercase letter, there are 26 uppercase letters, lowercase a to z, numbers 0 to 9. So if we'll add up this together, so this number will be 26, 26, 52 plus 10, 62, and punctuation marks are many more, so it will exceed the number 64. Only for these two, 26, 26 and 10, so the number is 62. To represent 62 different bits we need 6-bit code, therefore 2 raised to 6 will be 64. So 64 combinations will be there to represent all this, but we will not be able to represent all the punctuation marks, so just 6-bit code is not sufficient. So we employed a 7-bit code. So for 7-bit code, 7-bit code has 2 raised to 7, that is 128 combinations. So you can easily represent the alphabets, numbers and punctuation marks. So basically alphanumeric codes are used to represent the alphabet readers, punctuation marks, other specific characters in the computer system. Therefore these alphanumeric codes are broadly categorized into 2 parts. So very first part or the first code, what you can say is Ascii code. Now this Ascii stands for American Standard Code for Information Interchange, and it is pronounced as ASCII. So this is the pronunciation for ASCII code. This is worldwide accepted standard character encoding scheme introduced in 1963, and it is widely used in many computer systems, and basically it's a 7-bit code as I said here. So it is going to provide you 128 bit patterns. This will be including the small case letter, uppercase letter, special characters and the various functions for shortcuts for the computer system, just like Control plus C is copy, Control plus V is paste, like that functions will be included in this 128 combinations. Another code is there for the alphanumeric code, which is called as EBCDIC. and it is pronounced as Ascii code is the pronunciation for that. It stands for extended BCD, that is nothing but binary coded decimal interchange. This is developed by company JBM, and it also employed 8-bit code. So again what we have here is 2 raised to 8, that is nothing but 256 bit patterns will be there of 8 bits, and it is similar to ASCII. So this is all about alphanumeric codes.